amplitude and period. So think back, way back to the beginning of the year in chapter 3, when we did transformation rules. So to shift a function up or down, you add or subtract a number from the end of the function. So like the function x squared, if I add 3 to that, that's going to shift the function up 3. If I subtract 3, it would shift it down 3. To shift it right or left, we add or subtract inside the function. So x plus 3 squared is going to shift the function x squared to the left. So plus is left and minus is right. It's backwards. It's the opposite of how you think it should be. To reflect over the x-axis, we put the negative out front. All right, that'd be negative x squared. Or say negative square root of x for something that actually shows the difference between a horizontal and vertical reflection a little bit better. To reflect over the y-axis, we put the negative inside. So square root of negative x would reflect over the y-axis. And a vertical stretch or compression, we multiply by a number out front. If it's bigger than 1, it's a stretch. If it's a fraction between 0 and 1, it's a compression. If it's negative, that's this. The negative doesn't have any effect on the stretch or compression. The negative is a separate transformation. And then you also have a horizontal stretch or compression when you multiply by some constant inside the function. And if it's between 0 and 1, it's a stretch. And if it's bigger than 1, it's a compression. Again, backwards. So the amplitude of a function is whatever you multiply the function by outside the sine or the cosine. It's the absolute value of that. So if I have negative 3 sine theta, my amplitude is 3. The negative doesn't have any effect on the amplitude. It can also be described as the absolute value of 1/2 the difference of the maximum and minimum function values, which is useful if your graph is shifted up or down. All right, so we have this function. The amplitude of the function y equals 4 cosine x. So there's a 4 out front. The amplitude is going to be 4. Graph 4 cosine x and y equals cosine x on the same set of axes. So here, this is already the graph of cosine x. All right, this is y equal, would help if I actually left room to write things. This is y equals cosine x. And so then here in blue, 4 cosine x, right, this has an amplitude of 1. It goes up 1 unit from what's called the midline, which in this case is the x-axis. 4 cosine x is going to multiply all of your values by 4. So what was at 1 is now at 4, and points that were at -1 are now at -4, and the 0 points are still at 0. So the effect is that you get a function that is stretched. And let's do 2 and 2, -2 and 2, 2. And so you get a function that looks like this. Okay, so the effect of having the 4 out front is to stretch the entire function vertically by a factor of 4. So the high points are 4 times as high, and the low points are 4 times as low. So y equals 4 cosine x. the period of the function. The period of the function is, we talked about, it's the amount of time it takes the function to complete one cycle. So from the top to the top, or from the bottom to the bottom again, or one up and one down, whatever it takes to do one whole cycle. And our function of sine and cosine is typically 2 pi. But with transformations, we can change that. So the period, if we have sine theta or sine k theta or cosine k theta, the period is 2 pi over k. So if we have sine of 2 theta, your period is going to be 2 pi over 2, which would be pi. If we have sine of 1/3 theta, your period would be 2 pi over 1/3. When you divide by a fraction, you multiply by the reciprocal, which is 3/1, and so your period would be 6 pi. So a bigger number inside the function makes the period smaller, and a smaller number makes the period bigger. This is your horizontal stretch or compression. So y equals cosine of x over 2. We could also write this in a slightly more intuitive way as cosine 1/2 x. So then our period is going to be 2 pi over 1/2. And 2 pi over 1/2 is 2 pi times 2 over 1, which is 4 pi. So here's the graph of y equals cosine x. And if I was smart, there's the graph of y equals, this is in blue, this is y equals cosine x over 2. And then in red, this is y equals cosine x. So the period being 4 pi, now the function is stretched out because it takes 4 pi to do one cycle, whereas before it was 2 pi to do one cycle. So the period getting bigger means the function gets stretched out in the horizontal direction. State the amplitude and the period for the function y equals 1/2 sine 4x, then graph the function. So the amplitude is going to be 1/2, and the period is 2 pi over 4, which is pi over 2. So we start the function at the same point. Because the amplitude is 1/2, the high point is only going to come up to 1/2. It's only going to be half as high. The period being pi over 2 means that I need to do one full cycle in pi over 2 amount of space. So I need to hit my high point. I need to go a whole up and down loop in one of these blocks, a whole up loop, and then do a whole down loop in this block. And so, and the top of the up loop only comes up to 1/2, and the bottom of the down loop goes down to -1/2. And then I can just do this. It's not a very good drawing, but I'm a math teacher, not an art teacher. And that would be my 1/2 sine 4x. And erase this. That's a much better drawing. All right, so amplitude of 1/2, and we get 1 whole period of the function within pi over 2. All right, an equation of the cosine function with an amplitude of 9.8 and a period of 6 pi. So let's deal with the 6 pi first. Our period equals 2 pi over k. If we know our period is 6 pi and we want to make that equal to 2 pi over k, and we solve for k, multiply both sides by k, your k's cancel out, k times 6 pi equals 2 pi, and we divide by 6 pi, we get that k is 2 pi over 6 pi. So k, if you know the period and you're trying to solve for k is equal to 2 pi over the period. And the period is equal to 2 pi over k. So 2 pi over 6 pi, your pi's cancel out, 2 over 6 is equal to 1/3. So then your function with an amplitude of 9.8, you just put the 9.8 out front, it's a cosine function, and then the k is 1/3 x. I'd probably put parentheses around it just to be very clear. But that's it. That's your answer. And that's it for amplitude and period.